Hello and welcome back. In our last video, I introduced some of the basic concepts of the 8086 instruction set. And in today's video, we're going to be talking about a specific instruction that is used to manipulate strings. And this is a set of instructions. It can perform a series of operations on strings. And I'm going to explain to you what kinds of operations are possible and why this particular set of instructions are so powerful. But before that, what is a string? Right? And why is that such an important concept in the world of programming? So a string is nothing but a contiguous byte of sets of data, and it could be a byte long, it could be a word long, double word, doesn't matter, but it is a contiguous set of data somewhere within the memory of the processor. In this example, we have 10 contiguous bytes of data that represent some kind of information, and it's really, in this case, it's called a byte string. If this were a word, so that means it occupied 20 bytes of RAM, it would be called a word string, but again, just 10 contiguous locations as far as the processor is concerned. Now, let's look at all the elements in a string operation. Right, so you got a complete memory space, and in that memory space, you got a set of contiguous bytes of data which represent your string. So how would you represent your string? So remember, it's like a house address. You need to know the house number, you need to know the street number, the street name, you need to know the locality name, the city, the pin code, etc. Similarly, you need to identify a string through a set of parameters. The first one is obviously the start address of the string. Where exactly in memory location does the string begin? The second one is the end address. Where does it stop? Right? But then on top of this, you also need to define the length of the string. And you're going to ask me, hey, but just end address minus start address should give you the length of the string. Now that is an operation that is an overhead on the processor. So to make things better, to make it easier, you also provide the length of the string. In addition to this, you need to have, so basically in a string you can count either upwards from the start address of the string or downwards from the end address. So you can go up and down in the string. And to tell the processor what direction you're going to use, you use something called a direction flag. And the direction flag really is something it's a bit within the processor that indicates what direction the count is going, upwards or downwards. Okay, so what operations can you perform on a string? Obviously, you can move a complete string from one location to another. Right? So, for example, you got names of all the students and you've copied it in temporary storage. And you want to copy all the names of the student to another location, just as it is shown in this diagram. So the bottom part of the diagram shows you the first temporary location of the names of the students, and then it moves to the middle of the memory somewhere, which shows the final location where all these names ought to be stored. This is a typical string operation. Now, the bottom address, where the temporary, in this case the temporary storage location, the source locations is pointed to by the register DS, the data segment register. The destination location is pointed to by the extra segment register, ES. Obviously, both the data segment and the extra segment registers could be in the same physical memory space, it typically is. But you use the two registers to tell the processor that the DS is the source and the ES the destination for this string move operation. So how does this happen? So there are two instructions that can help you do this. One is called move SB, move string byte from destination to source. So move SB, destination address, comma, source address. This moves a byte of information from the locations pointed to by DS till the locations pointed to by ES. And then there is move SW, which is move string word from destination, comma, source. So the destination address, comma, source address. Now, important thing here is that these move instructions ensure that the sanity of the data is maintained, that the sequence of the data is maintained automatically. Now, this is if you didn't have the string instruction, what would you have to do as a programmer? Right? So let's assume you didn't have the move SB or the move SW instructions. First of all, you would have to move into the source index, the SI register, the source locations or the value from which the move must happen. Into the destination index, the DI, you would have to move the destination index values. I'm assuming that the DS and ES registers are already initialized. You would have to move the length of the string into CX, and then you actually start the move operation. So move into accumulator, because this is the equivalent of a move SB, right? So 1 byte at a time. Move into AL from the memory location pointed to by SI. Now SI is actually DS colon SI, that means data segment colon source index. The contents of that memory location move to AL, then move the contents of AL into ES colon DI, and basically therefore you have moved 1 byte of information from the source to the destination. You increment SI, you increment DI to point to the subsequent locations of the source and destination area. You loop back to move, and loop will automatically decrease the CX value. Right? So this loop, this set of instructions happens over and over again till CX becomes 0. Fairly costly set of instructions just to simply move a bunch of memory locations from one area to another. If you were to use the string operation, you still have to initialize the source index, destination index, and the count. You would also have to clear the direction flag, CLD. That clears the direction flag, just to say that it is counting auto increment. And then you have one instruction followed by the loop. So move S string 2, comma string 1, which means basically move from string 1 into string 2, loop back in the direction set by CLD, and wait till CX is 0, and everything is done. And this is a single instruction that can get performed in 4 clock cycles, like every other instruction, and then you just keep repeating this over and over again. Much simpler to program, very easy to debug, and much faster as far as the processor is concerned. What are the other operations that you can perform on a string? You can move a byte or a word from string into accumulator, which is called load string byte, load SB, or load string W, load SW, and this is really basically loading from a memory location into the accumulator. You do what you want with that information, come back and load the next one, so on and so forth. So really loading byte by byte or word by word from the string location into accumulator. Similarly, you can store from the accumulator into the string location. So that is STO, which is the store instruction. STOSB and STOSW perform the same things for byte and word store from accumulator into string memory locations. You can also compare two strings with each other. What you're really doing is, so let's say in one area you got the list of all the students, and then you got a list of all the students who are present in the class on one day. Is it the same list? Are all the students really present? It can be done automatically. Obviously, this is a trivial example. There, you can do this manually. But suppose you had a large chunk of data which you wanted to compare with another large chunk of data. This is a wonderful instruction to do that with. And the instruction is CMP, compare, CMP S. So compare string, CMP S, B or W. B for byte, W for word. And in this case, the CX register, of course, holds the length of the string. String 1 is pointed to by the data segment colon SI. The other string is the string 2, if you will, is pointed to by extra segment colon DI, so ES colon DI. If both the strings are identical, the 0 flag is set. So at the end of this operation, all you have to do as a programmer is to check the 0 flag and see if it is set. If it is set, you know that the two strings are the same. You can scan a string for a value. So let's say you got all the names of all the students, and you want a specific student called Rajesh. Is he there? So you could automatically do this with this one instruction called SCA. SCA is scan, SCAS is scan string, and you have SCASB or SCASW, which is scan string word or byte. And here too your CX registers, and string is pointed to by the data segment :SI. And after you finish the scanning, if the string contains the value, the zero flag is set. So as a programmer, all you need to do is run this string instruction SCA, check for the zero flag, and you know whether the string contains the value you are looking for. An important instruction that goes along with all these string instructions. So we talked about load, LOD, we talked about STO, we spoke about scan, we spoke about compare. All these instructions have an instruction that goes along with it, a special instruction called REP, and REP stands for repeat, and it is used only with the string primitives. REP cannot be used with any other instruction. It is used only with the string, and the REP is used as a prefix, and the primitive is executed till a certain condition is met. So what are the various conditions that you as a programmer can look for? So you've got REPE or REPZ, and these the compare and the scan operations use REPE, REPZ. So REP is equal to 0 or REP is not equal to 0. So REPNE, REPNZ. And what happens is this operation continues till the zero flag is set or the zero flag is reset, depending on whether you're comparing for 0 or not 0. The other one is REP, in which the REP instruction is used along with move, load or store instructions. And here what happens is the REP instruction repeats till CX is a positive number. The moment CX becomes 0, it stops executing the move, LOD or STO instructions. These are special usages that you have with the string operations. Using this set of instructions, the MOV string, MOVS, the LOD string, LODS, the STO string, STOS, scan string, and compare string, along with the REP, REPNE, or REPE, this set of instructions helps you to manipulate contiguous bytes of information or words of information called strings very easily, very efficiently, and absolutely as fast as it can be with the 8086. I hope this gave you a flavor and a feel for this complex instruction called the string. If you now read through it, you will begin to understand it much more, and you will begin to understand where to use it, why it is such a powerful operation, and it saves you time and the processor time when you use such instructions. In the next one, I'm going to be talking about a different kind of construction. It's called the procedure and the macro. We're going to understand what procedures are and what macros are. Till then, hope you begin to understand the string operation a little more. Thank you.